All right, a quick go through part D and then on to the last question. Been a long video, but I don't think anything too scary. First derivative here, the 1/3 comes down, subtract. Looks exactly the same as the last one. We got no solutions. Remember that x equals 4 gives us a critical point because the derivative is not defined. But when I analyze it, then because it's got this 2 on there, the bottom's always positive, or undefined. So when I do the derivative, um, this function's actually always increasing, except for that one spot, x equals 4, where it has a vertical tangent. F prime at x is undefined. Vertical tangent. Interesting. Okay, let's do example 2. Find all critical points of that bad boy and determine whether the points are local maxima or local minima. Same thing. Take the derivative, set it equal to 0, check out whether the critical points change signs to figure out whether maximums or minimums. All right, so y prime, this is going to be a quotient rule. You could write it as a product rule if you like. I'm going to take the derivative of the top, write down the bottom, subtract, write down the top, derivative of the bottom over the bottom squared, tidy up here, 4x squared plus 8x minus 2x squared all over x plus 2 squared, and I get, that looks like it can be factored, and it's going to be factored here in a second. 2x out front, x plus 4 in brackets. And so what do I got? Note, I have y prime is undefined for x equals -2, and then I'm going to solve y prime equals 0 otherwise, and I can see that the top is 0 when x equals 0 or x equals -4. I could, multiply there if you can't see that, right? As long as x is not equal to -2, then I got x equals 0 and x equals -4. Flying right along here, aren't I? F prime at x. Put those numbers on our sign chart. So we said it's undefined here, 0 here and here, and then I'm thinking about the sign of these things otherwise. So let's think about the sign of these things otherwise. So let's see. There's my f prime at x. So in here, notice that I have x is negative, so this is going to be a negative, times, and x is a big negative, so this is going to be a negative, over, notice the bottom's always going to be positive because I got something squared. It's going to be a negative but squared, so negative times a negative over this is going to be positive in here. And then in here, I've got something like -3. I could use my calculator if I wanted to, but I got a negative times -3 in here. This would be a positive, and this is going to be a negative, but it's squared. So this is a negative times a positive, which is a negative, over a positive. It's going to be negative. So this right here, what does this tell you? Even though -4 is a critical number, because it changed signs, I'm going to have a maximum or a minimum, and I'll think about that in a second because I'm rolling as far as this positive-negative business thing is concerned. So here I got a negative, and that's going to be positive over a positive squared. This is negative. So notice that we've got a critical number at x equals -2, but it doesn't change sign, so we're not going to have a maximum or a minimum in there. But now test point out here, we've got a positive. These are all going to be positives, right? Over a positive squared, positive, positive, positive. And notice I'm going to have right there, I'm going to have a local maximum because it change maximum or minimum because it changes sign. All right, well let's slow down a little bit here and think about this. So now I've got increasing, 0, decreasing. So what's that? That's going to be a max. Over here I have it decreasing, 0, increasing. This is going to be a min, isn't it? And so I could put these values into a chart to figure out what type of maximum and minimum that I've got. I wasn't asked for a sketch, but I certainly could include that one. It wouldn't be too tough. And I could get some values in there, but I don't really care because, oops, I had that backwards. This one's the maximum, and this one's the minimum. Local, minimum, maximum. What was I asked to do? I was asked to find all critical points. So, do we got critical points? At x equals -4 and x equals 0. I should find the y coordinates, but I don't really care too much about that. So, well, what about x equals -2? Well, this is what we were talking about here. Then explain why -2 is not a critical number, even though f prime at -2 does not exist. So last example, we had this case where the derivative didn't exist. But remember, one of the definitions of a critical point is f prime at 2 does not exist, but f at -2 doesn't exist, right? So when I put it in the original function, it also didn't exist there. So x equals -2 is not a critical number, and I'll point that. Go back in the note and point that out in a second. So look back. We'll look back. Look at all the stuff we did today. Holy moly! Where's the definition? Right here. Oh no, one more. Critical number if the first condition was that the function had to exist at that point. And in fact, in our last example, it does not. It does not, so that means it's not a critical number. Notice that if we wanted to, we could do a pretty quick MCV4U sketch of this, right? Where we think of, trying to make that where we've got a vertical asymptote at -2. I know it's got an oblique asymptote, right? Because this is one higher than the bottom. I could do long division and find that out. And somewhere I have, where was it? There it was. Asymptote at y equals 2x minus 4. So it looks something like this. Like that. That's the oblique asymptote. I could find zeros and that sort of thing. And check out things like behavior near asymptotes, and this is the hang on just a second, what's going on here? Oh yeah, and this is the sort of functions way. Well, what have we added? Well, we know that a maximum occurs here and a minimum occurs there. In fact, that's 0. If I were to put that back in to the original function, x equals -4 is 2 times 16, 32 over -2 is -16. And that actually, oh, I remember Mr. Restall in functions would circle that and say MCV4U. Well, here we are, folks. There's this point is a local maximum, -4, -16. There's my low. This one was we might have been able to get in functions, but this is a local minimum, 0, 0, right? Just like we knew from the first derivative. And now we're being able to add a little more detail to our sketches. And of course, um, the final story for this whole chapter is to be able to graph this in quite some detail, any function in quite some detail. We've got more concepts to talk about, but that's a lot of stuff today, and hopefully you know, understand the difference between a critical point and a minimum or a maximum.